Welcome back with another video on TryHackMe.com. This is Zahi Nazir and we are doing not on premises. Why? Because the last task, second last task, which is attacking on the premises IaC, is a little bit challenging. I'm not able to complete it yet, but I promise you, before we complete this part, I will be able to do it and create a video for you. But in the meanwhile, let's go to the infrastructure as a code and start our cloud-based IaC. So once we are about to complete this one, I will release the task 7 for on-premises IaC. Apologies for that. Let's continue. Cloud-based IaC, learn about infrastructure as a code IaC using tools for cloud deployment. It will take 180 minutes. So that means 3 to 4 videos will create and will cover all of this room. So let's see what we have in the introduction. Task 1 introduction. Explore the fundamentals of infrastructure as a code and its crucial role in modern cloud computing. We will focus on cloud-based IaC use cases, while AWS Cloud Formation and Terraform that enables the creation and management of the cloud resources in a scalable, efficient, and secure manner. Learning prerequisite. From task 2 onwards, concepts and tools characteristics defined in the intro to IaC room or reference. So it would be a good idea to have this done. We already have covered this one, and I will reference this one on the YouTube video over here. A learning objective, understanding cloud-based IaC concept, secure infrastructure as a code practices, security consideration in the cloud-based IaC. So there is a banner for a film kind of thing. Come with me if you want to build infrastructure as a code, DevSecOps, TryHackMe. All right, awesome. So let's continue. Oh, our streak is increased. Task 2, Terraform 101. Okay. Terraform overview. Terraform is an infrastructure as a code tool used for provisioning that allows the user to define both cloud and on-premises resources in a human-readable configuration file that can be versioned, reused, and distributed across teams. Terraform uses a consistent workflow to make the management of your infrastructure as easy and reliable process. Both this configuration and the workflow Terraform follows will be covered by a subsequent task in this room. For now, let's define some terms which are key to understanding how Terraform provisions and manages the infrastructure. Okay, so here is our AWS machine, and there is assembly line. We have some robots which are being configured, and as you can see from their eyes, they are already angry and they have suspicious smile on their faces. Okay, and there is a TryHackMe logo here. Okay, Terraform's architecture. Now we know that the Terraform does what Terraform does. Let's examine how it is done. We will examine the Terraform's architecture. Sure. Terraform Core. As the name suggests, the Terraform Core is responsible for the core functionalities that allows users to provision and manage their infrastructure using Terraform. As mentioned in the intro to IaC room, Terraform is declarative tool. Reminder, this means that a desired state is defined and the tool is responsible for ensuring the infrastructure meets that desired state, rather than the user declaring each step required to achieve the desired state. To ensure the user infrastructure is in the desired state, Terraform Core takes its input from two sources: Terraform config file and then state. Okay, Terraform config files. The user defines the desired state of their infrastructure in these config files. In other words, what resources make up their desired infrastructure state. Terraform has a state file that keeps track of the current state of the provisioned infrastructure. The core component check this state file against the desired state defined in the config file, and if there are resources that are defined but not provisioned, or the other way around, makes a plan of how to take the infrastructure from its current state to the desired state. By default, this state file is called terraform.tfstate, and is stored in the same directory where the Terraform runs. Okay, so we have user, it defines the configuration files, which will have the desired state. This desired state will go as a parameter to Terraform Core. Now Terraform Core have two inputs, take input from two sources. One is the desired state and the other one is the actual state, and then it will perform the actions. And we are using AWS as a provider here. A provider could be changed, could be any other cloud provider here. We can see in the graphic above that the Terraform Core takes its input from two places, the user-defined config files and TFS state. Should there be any difference between their desired state config files and the current state TFS state, the required action will be executed using a provider. The plan mentioned above is executing using different providers depending on the resources. Defined providers are used to interact with the cloud providers, SaaS providers, and other APIs. For example, if AWS resource like EC2 instance is defined, the AWS provider would be used. If a Kubernetes cluster is defined, the Kubernetes provider would be required. Awesome. So here is our plan, and this resource will be terminated, destroyed. Okay. He already have a gun, maybe MP5 or something, and it have AWS logo, and there is something with his eye. It is bionic eye. Okay. The tool and its architecture boasts many benefits of this IaC tool for DevSecOps engineers. What probably sets Terraform apart the most from other IaC tool is the ability to use these providers to provision and manage resources across multiple cloud providers. This means if you are working with an infrastructure that has infrastructure resources with AWS and Azure, Terraform can be used as a single solution for multi-cloud environment. This is very true. That's why it's very famous as well. This also prevents vendor lock-in and means the infrastructure can be much more flexible. Another benefits of the Terraform is the declarative configuration language, which is used to define resources in config files. It's easy to understand, and the human readable format makes the definition processes simple and streamlined. On top of all this, declarative nature of the tool supports versioning and change tracking practices, allowing team members to collaborate during the declaration and development of the infrastructure and roll back to previous infrastructure iterations. The next task will go into the further detail on how these resources are defined. Okay. Terraform Core takes its input from two sources. This source keeps track of what the infrastructure currently looks like. What is the name of this resource? What does infrastructure look like? State, right? We call it state or FS state. Yeah, it is a state. Other source defines what you want infrastructure to look like. What is the name of this source? Config file. Is it configuration file or desired config file? Terraform config files. Yeah. Okay, we put it here. Oh, well, this is what they are asking. Yes, if there is a difference between what the infrastructure currently looks like and what you want it to look like, this will require a change. This change will be actioned by a Terraform Core or provider. Awesome. We are already to the task 3, which is Terraform configuration. All right, let's see what we have here. Terraform configuration and Terraform. Now that we know what Terraform is and how it works, let's take a look at how we would define the desired state using Terraform config files. Terraform config files are written in a declarative language called HCL, HashiCorp configuration language. which, as discussed, is easy to understand and human readable. The primary purpose of this language is to declare resources. These resources represent infrastructure objects. The combined definition of these resources make up the desired infrastructure state. Okay, awesome. To give you an example of how, as a DevSecOps engineer, Terraform configuration files might be used, let us consider an example where we want to define a simple VPS, virtual private cloud, using the AWS provider that would look like this. Okay, so we have provider AWS, we have region where it will be deployed. Then we create the VPS resource AWS underscore VPS flynet VPS. The CIDR block is 10.0.0 and 16 is the mask value. Then tags is flynet VPC. Okay. The Terraform company file might be used. Let us consider an example where we want to define a simple VPS. Okay. What does the code do? After defining our provider, which is in this case AWS, this resource block is used to define a VPC. We first define the resource by stating the resource type, which in this case is an AWS VPC, and then what we will call this resource. The example is flynet VPC. The virtual private network or something. Then begin our resource block where we define our resource arguments. The argument given will depend on what type of resource is being defined. For example, an AWS underscore VPC will need a CIDR block method for allocating the IP addresses. We also define tags which can be used in AWS to help with the automation of the resources, building and access control, etc. Okay. Resource relationships. Okay. Sometimes resources can depend on other resources. When defining a resource with dependencies, the resources it depends on will be referenced. For example, if you were assigned a task to define an AWS security group ingress rule, allowing SSH access from any source within the VPC, you would add the following code block to your configuration file. Okay, we have resource AWS underscore security underscore group, example underscore security underscore group, name is example dash security dash group, description is example security group, VPC underscore ID is equal to AWS underscore VPC. Okay, there are a lot of things, moving parts here. Reference to the VPC created above, format resource type dot resource name dot ID. Okay, so this is how we gonna reference it, and we are creating these security groups here. So the ingress rule is where the traffic will come inside this network. Rule allow SSH access from any source within the VPC ingress. Since we are allowing SSH traffic, we from port and to port should be set to port 22. From and to port are 22, and the protocol is TCP. Side blocks should be from AWS VPC.flynet VPC.ciderblock. So only the resources that are within this, which have the IP address of this CIDR block, will be able to do the SSH to within this network. Okay, this is what we are creating the security group itself. What does the code do? Here we can see we have a resource block that defines an AWS security group, helps secure AWS environment by controlling how traffic is allowed into the EC2 machines, which allows SSH access from any source within the VPC. You can see in the commented lines how this is configured and how resources can be referenced from within another resource block. Okay, infrastructure modularization. As a DevSecOps engineer, you will likely work with a large complex infrastructure. Another benefit of Terraform is that it allows for modularization of an infrastructure. That is for infrastructure to be broken down and defined as a module, as modular component rather than in a single place. This is common practice in larger organizations, as it simplifies the management of complex infrastructure configurations. Let's take a look at what the above example configuration would look like. Below is a representation of directory /tf config and the files within it, with a brief comment explaining the purpose of each file. Okay, so we have tf config, and then we have a parameter, I think, or it is a file here, flynet underscore vpc underscore security.tf. Like mentioned, instead of having all resources defined in one file, resources can be paired up and defined in a separate modular files. Other modular.tf file, and then we have variables.tf file. Some values will be used across two or many infrastructure modules. So instead of declaring these repeatedly in each.tf file, it makes sense to parameterize them in a file called variables.tf. These variables can then be directly referenced in the .tfs file. Main.tf acts as the central configuration file where the defined modules are all referenced in one place. Awesome. If we consider the example given above, if we were to define a VPC using this structure, it would be configured like so. Okay, so we have variable, we have VPC underscore CDR underscore block, and then we have description, CDR block for VPC, type is string, default value is this one. So this will come into the variables, and the file name is variables.df. Okay, we are defining a VPC the same way as did at the beginning of this task, except we are storing it in a variable.tf file. We're doing this so we can reuse reference it. This could be referenced in any module.tf file. For example, below we have a code block for a module name flynet underscore vpc underscore security, and then inside here we have CDR block, which is a variable, and we are assigning the value var vpc CDR block. Okay, all right. Variable can be referenced using var followed by name, variable name. So we have variable name, this one. So it will basically assign the value, the whole value here, I think, to CDR block, or just the default value here. Okay. Finally, this module and all other modules TF files would be collected and referenced in the main TF file like so, main.tf file, and then we have module which is flynet underscore vpc underscore security. The source is this one, flynet vpc security.tf, where the module is defined relative to the current file. Okay. Basically it is in the same folder, so this is what we are using. Other modules source is the other module.tf file. Okay, the level of organization would be extreme given how primitive the infrastructure setup is in our example. However, this was to show you how an infrastructure at scale might be configured in a larger organization or company. All right. When defining the VPC in the first example before the resource block, what was defined? VPC. Before defining the VPC, what was defined? Provider, right? Yeah, I think so. Not sure, but let's see. Yeah. When modulating your infrastructure, what file acts as a central config file? Main.tf. Alright. Instead of repeatedly defining values across multiple infrastructure modules, this value can be collected in one file and referenced. What is the name of this file? Okay, instead of defining values across multiple infrastructure modules, these values can be collected in one file and referenced. What is the name of this file? I think variables.tf. Variables.tf. Yeah, awesome. So this was it for today. Unfortunately, we have less time to do everything here. So once we come back, I hope to cover, I think, 4, 5, and 6 at least, and then at last we'll cover 7, 8, and 9. Or before even that, maybe tomorrow I will try to complete the video for on-premises practical example, practical task, which is task 7, and make sure that you already enable the notification and click on the bell icon to make sure that you get the notification. So that's it for now. Thank you guys. If you haven't subscribed, please subscribe. If you like this video, please give it a thumbs up. If you have any suggestion, please put it in comments below, and I will see you in the next video. Thank you.